Let us discuss about the power in an AC circuit. While calculating power, the general formula in current electricity we can write as the product of voltage and current. P is equal to VI. Applying Ohm's law, we can write the same as I square R. In the same manner, we can even rewrite the same formula as V square by R. But in AC circuits, same power we used to calculate slightly in a different manner. The basic formula for average power is IRMS into VRMS into cos phi. That phi in fact is the angle between IRMS and ERMS. That's what officially we call it as phase. And here this cos phi, that term, we call it as power factor. So how to just calculate the power in different circuits of AC? Let us take up. Power in an AC circuit. What is the equation for this? Just now I have given you, that is I virtual into E virtual into cos phi. Let us now write an equation to get that equation first. We can write directly power as rate of doing work. Power by formula, we can write dW by dt. Therefrom, we can write dW is equal to P dt. Let us just consider the alternating EMF is E naught sin omega t. In the same manner, the instantaneous value of current, let us write the same as I naught sin omega t plus phi. In fact, this phi directly gives us the phase difference that is existing between this EMF and this value of current. So when we talk about dW, that now can be rewritten as voltage into current into dt. That is the basic equation. But here we can rewrite the same as E into I into dt. E for EMF, I for current, and dt is the variation in temperature over there. It's variation in time. That is variation in time. Now E into I into dt. But what is E? We have specified here. What is the value of I also we have specified? So let us work out dW in terms of these two given equations. Let us write E naught sin omega t into the value of I naught sin omega t plus phi. This dt will be there. So this work done, whatever we are going to calculate, that is E into I into dt. E we have written E naught sin omega t. I we have written I naught sin omega t plus phi. Dt is as it is. We can rewrite the same equation this way: E naught I naught sin omega t into sin of omega t plus phi. That can be written sin omega t cos phi plus cos omega t sin phi. this dt will be as it is. So I just have expanded this one into sin A cos B plus cos A sin B form. We can rewrite the same E naught I naught sin square omega t cos phi plus sin omega t cos omega t sin phi dt. But we can write sin square omega t as 1 minus 2 cos omega t, that is 1 minus cos 2 omega t by 2. We can rewrite the same this way, E naught I naught into 1 minus cos 2 omega t by 2 into cos phi plus sin omega t cos omega t can be written as sin 2 omega t by 2. So we can rewrite the same sin 2 omega t by 2 into sin phi whole into dt. This is the equation. Now multiplying with cos phi, what is it we can expect? dw is equal to E naught I naught by 2. I can take that one common. Cos phi minus cos 2 omega t cos phi. Cos phi into 1 minus cos 2 omega t into cos phi. See the second term plus sin of 2 omega t into sin phi. This into dt. But when we want the net work that has been done in the system, we should integrate this one. So w now is equal to integral 0 to t. One complete wave we are considering. The time period in one complete wave is going to be capital T. So that capital T we are taking as the upper limit here. So 0 to t, between the limits, we just have to integrate this total lot. Integral 0 to t E naught I naught by 2 into cos phi minus cos 2 omega t cos phi plus sin 2 omega t sin phi dt. Let us now rewrite the same this way. E naught I naught by 2. You take this one, integral 0 to t cos phi dt minus integral 0 to t cos 2 omega t cos phi plus integral 0 to t sin 2 omega t sin phi dt here, dt here. Now we have to integrate this whole lot. E naught I naught by 2. This now becomes cos phi into t minus, now here this cos phi, if I take out of this integration, this now cos 2 omega t becomes sin 2 omega t by 2 omega plus sin phi, if I take it out of this integration, this becomes minus cos 2 omega t by 2 omega. But between the limits 0 and t we have to write. This is the total value we can expect after integrating this above equation. Now the case is E naught I naught by 2 into cos phi into t, till this extent same. Now we can rewrite the same this way: cos phi sin of 2 into 2 pi by capital T into small t by 2 into 2 pi by capital T between the limits 0 and t plus sin phi into minus cos 2 into 2 pi by capital T into small t by 2 into 2 pi by capital T between the limits 0 and t. If you carefully observe this one, this upper limit when I substitute here, t gets cancelled, you are left with the sin of 4 pi, which will be 0. Lower limit when I substitute there, that directly becomes sin 0. That also is going to be 0. So this total value will be 0 now. Now check the second one, the last term in this order. Minus cos 2 into 2 pi by t into capital T when I write. Upper limit when I substitute, it becomes minus cos 4 pi. That no doubt becomes minus 1. When I substitute 0 in place of that value of t, that is a lower limit, now you will be getting a plus 1 there, so that again this will be 0. So these two they get cancelled. What now is remaining? Just look at it. So what is the ultimate result we are getting from this? Work done is equal to E naught I naught cos phi into t by 2. But in fact our intention is not to calculate the work done in this case. Work alone will not be our resultant. Our result is to calculate the power. Therefore, we can write power is equal to work by time. Then this t getting cancelled, you will be left with E naught I naught cos phi divided by 2. E naught I naught cos phi divided by 2. Same equation we can even rewrite it like this: E naught by root 2 into I naught by root 2 into cos phi. One can straight away understand E naught by root 2 is ERMS. I naught by root 2 is IRMS. So what can we write now? This is E virtual into I virtual into cos phi. This power we call it as average power in any AC circuit. So the average power value we now have derived. What is that equation we are getting? EV into IV into cos phi. This is virtual value of EMF, this is virtual value of current, and phi gives us the angle between these two. That's what that virtual value of EMF is making an angle with virtual value of current, that otherwise we can call it as phase. So this is the final outcome as far as the power in an AC circuit that's concerned. But we have already discussed several circuits earlier of AC. One exclusive resistance circuit we have taken, an inductance circuit, a capacitor circuit, then combinations we have discussed. In all those circuits individually when we take them, what would be the power in each case? That's what we have to discuss now. How this power that varies in each and every individual circuit, what we have taken up earlier. So let us start with exclusive resistance circuit, that's pure resistance circuit. What is the power in that circuit? Let us start with that. Let us calculate the average power in a pure resistance circuit. In a pure resistance circuit of AC, what is this average power in the case of only resistance circuit? We in fact know in the case of resistance circuit, both the virtual EMF and virtual current values across the resistance are in the same phase. There is no phase difference between these two. When both are just in the same direction, what would be the value of phi now? It is taken as 0 degrees. The moment current is in phase with EMF or EMF is in phase with current, whatever we say, the angle between them is to be 0. Then phi becomes 0. But we know the average power is equal to virtual EMF into virtual current into cos phi. Since phi is 0, cos phi becomes 1. Therefore, we will be getting this formula as EV into IV. In fact, this is to be called the maximum value of power. So, when can the power be maximum in an AC circuit? Power becomes maximum when cos phi value becomes 1. That is the identification we need to have here. So, in the case of pure resistance circuit, the average power is going to be maximum and the value of phase angle is going to be 0 degrees. The maximum value of power now becomes EV into IV. That is the concept. Now, if you take the second one, that is in the case of pure inductance circuit. Let us just calculate the power in the case of pure inductance circuit of alternating current. In the case of pure inductance circuit, current lags behind the EMF by pi by 2 radian. In other words, we can say EMF leads the current by pi by 2 radian. So, what we have to draw here, if this is the value of virtual EMF, the current in this pure inductance circuit is going to be lagging behind this value by pi by 2 radian. So, or else EMF can be taken as if it is leading the current by pi by 2 radian. Therefore, what would be the average power? It is again EV into IV into cos of pi by 2. The angle whatever we are getting here, that is to be called the phase. So phase is now going to be pi by 2. Since cos pi by 2 is 0, you will be getting the corresponding power in pure inductance circuit is going to be 0. So in the pure resistance circuit it is maximum, it's EV into IV, whereas in pure inductance circuit its value is 0. So this is the second one. Let us consider capacitance circuit of AC. In the case of only capacitance connected across an AC source, then we find if this is the direction of virtual EMF, current leads this value by 90 degrees. That is pi by 2 radian. This will now be the virtual value of current. Current leads. What is the equation we people used to generally write? E is equal to E naught sin omega t. If this is the equation for EMF, I becomes I naught sin omega t plus pi by 2. That is the case of current. So since current is leading by pi by 2 radian, again we can say that phi becoming pi by 2. Due to that, the average power when we write, it is EV into IV into cos phi again. This again becomes 0. So in the case of exclusive capacitance circuit, average power will be 0. In the case of exclusive inductance circuit also, average power is 0. Only in the case of resistance circuit, the power becomes maximum. Let us now take the combinations. The very first combination in LR circuit of AC. In the case of LR circuit, if I consider this is the voltage across the resistor, then we can understand the virtual value of current will be along the same phase of that VR. It will be in the same phase with respect to that VR. Whereas the value of EMF, that is the voltage across inductance, that now leads this current by pi by 2 radian. Due to this, the virtual value of EMF, we used to write it like this, the virtual value is equal to root over VR square plus VL square. Now if I say the virtual value is making an angle phi with the direction of current, then how to write the value of cos phi? You understand from this circuit. From this particular graph, you understand this cos phi value adjacent by hypotenuse. Adjacent value is going to be VR. Hypotenuse value is going to be EV. What is the effective value of EV we know. Therefore, VR by root over VR square plus VL square we can write. Same equation we can even rewrite it like this as R by root over R square plus XL square. And in fact, we can rewrite the same this way also. Cos phi is equal to R over root of R square plus omega square L square. This is the power factor in the case of LR circuit. The moment we know what is the power factor in this particular circuit, then automatically one can write the average power that is existing in that. What is the average power of that circuit now? According to the equation, E virtual into I virtual into cos phi. What is cos phi? Already we have kept it ready here. Substitute that value here. You be getting EV into IV into R by root over R square plus omega square L square. This is one form of the equation for power. One more form you better remember this way also. According to Ohm's law, I can be written as E by R. Now in this particular case, you can rewrite the same this way. Power average is equal to E virtual into, in place of IV, I can write E virtual by Z. Z is called impedance, into this value of R by root over R square plus omega square L square. But we all know the value of impedance in LR circuit is again the same, root over R square plus omega square L square. Therefore, you can rewrite the same this way, E virtual square into R divided by R square plus L square omega square. This is another version for the same power in LR circuit. So as far as the power concept that is concerned in an LR circuit, one should remember this formula as well as this other equation what we people have taken up here. So there are two different ways of representation. One is E virtual into I virtual into R by root over R square plus omega square L square. The second equation is E virtual square into R by R square plus L square omega square. So this is another way of representing the same formula. This is regarding LR circuit what we have.